Hello everyone, welcome back to Diksha Karnataka YouTube channel, and you are watching Sankalp KCET 2026, and as usual we are going to discuss the second part of wave optics. Here we are going to discuss interference, diffraction and polarization. So if you have missed the first part, go and check that out. There I have discussed mainly about wave theory, coherent, incoherent sources, etc. Now before I start, I always ask you to subscribe to our channel if you have not yet subscribed, and secondly join our WhatsApp channel. The link of the WhatsApp channel is given in the description. All the PDFs, all the good things are happening there, so definitely you have to join to our WhatsApp channel. And if you follow my instruction perfectly, then you can feature over here. This is the last year's YouTube batch rank, and as you can see, all the students, they have performed exceedingly well, and here your picture, your name and your picture can be here featuring next year, right? So follow my instructions and follow my lectures from the beginning so that you can achieve a dream rank and feature in our segment, right? Now let's look into the chapter summary. So first we have discussed wave theory, Huygens principle, coherent and incoherent of light. Second, we have today we are going to discuss superposition principle, interference of light, Young's double slit experiment, diffraction, polarization and Malus law. These are the very important portion, and from this portion 2 questions will come in your KCET exam. So if you are watching today's video, it will not be super long, but definitely if you watch it, you can definitely score 2 questions, 2 marks, which is very important and not super difficult if you follow this lecture, right? Now let's see what is superposition principle. At a particular point in the medium, the resultant displacement produced by a number of waves is the vector sum of the displacement produced by each of the waves. What is the meaning of that? Suppose we have a wave, okay, we have a wave which is traveling. It reached some point P. Some another wave which is also traveling, by chance it also reaches the same point P, and another third wave which is also traveling, it also reaches the same point P. So 3 different waves traveling at 3 different directions, suddenly they meet at a point P, right? Now what will be the resultant displacement or resultant wave at P, which is our point of concern. So for the basic theory is, whatever is the displacement of this wave, displacement is a vector quantity, right? It can be determined at particular point, particular time from the wave equation. So if you find all the individual displacement and add them up vectorially, so if someone is plus, so you add them as plus, if someone is minus, you add them as minus. So if you add properly, then whatever is the resultant value, that will be the resultant displacement at this point. This is simple superposition principle. Okay, suppose we have a wave which is represented by y1 equals to a1 sin omega t at this point P. So this is wave y1, this is wave y2. We are only considering 2 waves, not 3 waves. Okay, this is just to explain you, but suppose 2 waves y1 and y2, they are meeting at this point P, and at this point the displacement of the wave y1 is given by a1 sin omega t, and displacement of another wave y2 is given by a2 sin omega t plus phi. What is this term phi? Phi is the phase difference between these 2 waves. Phase difference can be constant, then it will be a coherent light. If the phase difference varies, then if it is not a constant term, then it will be a incoherent light, right? If phi is constant, that means if suppose phi is say 5 degrees or 10 degrees, it is constant, right? So in that case it will be a coherent light, but in some case phi may be a function of time, or phi can be a random number. In that case phi is not constant, so it will not be a coherent light. Generally we whenever we consider any superposition principle or any light interactions, generally they are considered to be coherent sources of light. And once they meet at this point, what is the resultant intensity? That is our target, to find the resultant intensity, resultant amplitude. First step is to find the amplitude, resultant amplitude. Resultant amplitude means if you add these 2 waves, there are ways to do that. Okay, add these 2 waves, that is y this is the resultant amplitude r sin omega t plus theta. Okay, so theta is the new new angle, new phase angle. So if you add these two waves and get a resultant displacement like this, then this is called the final wave or the resultant wave. Okay. Now this is very important to find this amplitude. This is the resultant amplitude. Okay. This is the initial amplitudes A1 and A2. Both waves had different amplitudes, they are not same, and once they superimpose on one another, then what is the resultant? That is our first target, and it is simply the vector addition formula. If you remember vector addition formula, A1 a square plus b square plus 2ab cos theta. Similarly here a1 square plus a2 square plus 2ab a1 a2 cos phi. Okay, so simple vector addition formula. Now for lights, amplitude means not so much. Here we have to find the intensity. Now what is the relationship between intensity and amplitude? Amplitude is related to intensity. How it is related? So intensity is basically always proportional to r square, or intensity of light is proportional to amplitude square. Okay, always remember that that intensity is directly proportional to the amplitude square. Similarly here also you can calculate this as r square. Now what is the intensity of this wave? So intensity of this wave I1 was proportional to a1 square. What is the intensity of this wave? Intensity of this wave is proportional to a2 square. Okay. Now if you put these values over here and simplify a little bit, then you can find the resultant intensity to be I1 plus I2 plus 2 square root of I1 I2 cos phi. Now those who are preparing for JEE mains, based on this formula, there are a lot of questions that has come in the past, right. So this is a very important formula for JEE main students. Okay. And in some cases you can particularly for certain angle of cos phi, specifically if phi is equals to 0. So cos 0 is 1. So you can show that if phi equals to 0, then intensity becomes square root of I1 plus square root of I2 whole square. This is another formula. Okay. Now if, so this is a particular case. Now if I1 is equals to I2 and equals to I0, so both waves have same amplitude, same intensity. If both waves have same intensity, then the resultant intensity becomes 4I0 cos square phi by 2, cos square phi by 2. Very important to remember. You can just simplify this equation and find this out, and based on this you might see some questions. Phi will be given and I0 will be given. You will be asked to find the final intensity. That is a KCET level question. Okay. Mostly formulas are there, some derivations are not super high from this portion. Now interference of light, this is the first major point of this discussion today. A phenomenon that occurs when two or more coherent light waves interact with each other, causing the combined amplitudes of the waves to increase or decrease. So interference is the same thing as superposition, but when coherent light superimpose, right. If the lights are not coherent, superposition principle is still valid, but if the lights are coherent, then definitely the thing that you will observe is called interference of light. So intensity of light changes, okay, at some point, and it happens throughout the position, throughout the screen. You have to have a screen to observe the interference pattern, and you will see that at some places intensity is very high and some other places intensity is very low. Okay, we will come to that while discussing Young's double slit experiment. So this is the basic structure of Young's double slit experiment only. Okay, what he has done, here we have a source. Okay, I discussed it in the last class as well. Here we have a source, single point source, and here we have two different slits. Slit means what? You take a blade you take a razor blade, and if you cut this is a paper by that blade, there is whatever is the opening, that opening is called slit. Okay, this opening is called slit. Generally this source is not a single point source, it is a line source, and even the slits are also line slits. Okay. So, for that what happens is that the light initially from the source reaches to S1 and S2 in equal amount of time. Both the slits are at equal distance from the original source. So, what happens? So, we know that if light travels in the same distance, then it is basically the primary wavefront, right. Huygens principle, same time means they are located in the path of the source, that means it is a primary wavefront. Now, each point on the primary wavefront will behave as the secondary source of wavelets, right. So, this slit, this opening, these two openings, they will also behave as secondary sources. So, this is the secondary sources, there are no direct lights here. As I said in my last class, two different sources cannot produce coherent light. Two different sources cannot produce coherent light. That is why we are taking one single source and splitting that source into two sources by using this simple method. It is very simple method. Okay. So, once this light source is split into two separate light sources, now they are basically the two independent sources, and from here on whatever we are observing, the light rays, these two rays are basically coherent rays. Okay. Any ray of light if you consider, okay, they will be coherent rays. Okay. And we will observe some pattern. This is our screen. This point has a very special point called central maximum. Why it is called central maximum? So, if you consider the light ray travelling from S1 to O, now at this point they are in phase, right, their phase difference is 0. At this point their phase difference is 0. Now, light ray which is travelling from S1 towards O and light ray which is travelling from S2 towards O, they are also travelling the same distance. Same distance means time should remain same, speed is same. So, if distance is same, then the time should also be same. So, the light ray which starts at S1 at t equals to 0, suppose after t second it reaches at point O. Similarly, the light ray which is starting from S2, it will also reach O at the same time. So, from at t equals to 0 both were here, and at t equals to t both lights are there, right. So, basically for this particular point the phase difference is 0, because both of the light is taking same time, same distance, but we cannot say that for this point P. So, as you can see, this point P is closer to S1. So, S1 will take less amount of time to reach P, but S2 will take slightly longer amount of time to reach point P, right. So, there will be a phase difference, and phase difference is not equals to 0, right. Phase difference will be 0 only for this central point. This is the center. If you join the original source throughout the midpoint of these two sources, then whatever point you get, that is called central maximum. This is a very special point in interference of light. Okay. For most of the interferences we will always see a central maximum. Okay. Now, based on the light which are imposing on another, okay, there can be conditions for maximum and condition for minimum. Now, let us discuss that in the Young's double slit experiment. Suppose the light in general we will consider this point P. This P point is random point, it can be anywhere on the screen, not the O point. O point is a very special point. Other than O, any other point, what happens is that suppose light is travelling like this, right. Here also light is travelling like this. Now, when the light reaches point P, suppose from S1 the light travels like this at point P. From S2 also the light travels like this. Light is wave. Wave means what? This is a wave. It can have two things, right? So from this is S1, it is reaching like this. Similarly, from S2 also it is reaching like this. So this is the point P. So at point P, both lights reach at the same phase. Basically, they both have the maximum phase peak position. Then what happens is that at this point you get a resultant wave. You get a resultant wave which has much higher amplitude. Okay, this is the resultant wave. So for resultant wave the amplitude increases. This is called interference maximum. This is called interference maximum or constructive interference. Constructive interference. And because it appears to be like fringe. Fringe means what? Fringe means like the ribbon. Okay, fringe is basically a term used for ribbons. Nowadays we do not use fringe, we use ribbons. That is similar to that of the fringe. Okay, and because they appears to be bright colored ribbons, and that's why they are called bright fringes, right? So this is called constructive interference. Constructive interference means both the rays, both the light are at maximum, at their maximum position. Okay, once they interfere like this, so we observe something which is called interference maximum. Okay, and this region appears very, very bright. Okay, this region appears very, very bright. Now, what is the condition for that? Condition for that, it can be shown mathematically. The mathematics part was part of your syllabus few years ago, but that mathematical portion is no longer part of the syllabus anymore, but you can find this out. The path difference is, if the path difference, what is the path difference by the way? What is the meaning of path difference? Let us go back to the previous slide. Path difference means, suppose you take this path, how much distance is travelled by S1. Suppose this is the distance travelled by S1. You take this line and you make it straight. What is the distance travelled by S2? This is S1. S2 definitely travel more. So if you take this out and make a straight line, so this will be your S2 straight line. Both will be straight line. Okay, if you make the both lines straight, okay, then whatever is the difference between these two paths, whatever is the difference these two paths, this is called path difference. Okay, this is called path difference delta x. Okay, this is called path difference delta x. Now, so this path difference delta x, if it is integer multiple of wavelength lambda, wavelength of light lambda, if this is an integer multiple, integer means 0, 1, 2, 3, 4 and their negative terms, plus and minus. Okay, for all points, if you consider the screen, all points above the central maximum are positive, this is negative. So for positive n, you get all the points above, for negative n, you get all the points below. So plus 1 means upside, minus 1 means downside, that is it. Okay, so delta x equals to n lambda, okay, for integer n, 0, plus minus 1, plus minus 2, etc. So if the difference in the distance travelled is integer multiple of lambda, then you get constructive or bright fringes. Now for the central maximum, value of n is equals to 0. Okay, value of n is equals to 0, and which satisfied the condition for constructive interference. So here you observe a very bright fringe, that is why it is called central maxima. Okay, this is called central maxima. Here you observe a very bright fringe, bright spot, bright patch. Okay. Now the phase difference in terms of angle, y1 is equal to a1 sin omega t and y2 is equal to a2 sin omega t plus phi. So that phi. Now in case of Young's double slit experiment, both lights have same amplitude, same intensity, that is A1 equals to A2. A1 and A2, they are not different, they are same, phi is different. Okay. So, what is the relation for phase difference? Phase difference will be 2n pi. So, if the phase difference is 2n pi, where n is same, 0 plus minus 1 plus minus 2, then you get constructive interference. Now, there is a relationship between phase difference and path difference. You have to remember this. Based on this, if you are appearing for KCET, if you are appearing for COMET K, or if you are appearing for JEE Mains Advanced, this formula is very, very important. Okay, 2 pi by lambda into delta x. Okay, so phase difference, relationship between phase difference and path difference is 2 pi by lambda into delta x. So, if you put n lambda over here, okay, lambda cancels and you get 2n pi. So, 2n pi is the condition for maximum interference or constructive interference, right. And position of the bright fringe. What is the position of the bright fringe? Position of the bright fringe on this axis. Okay, suppose this position is y. Okay, so this is the, suppose this is the point where we are observing, and we have observed a bright fringe, okay, bright spot. Then position is given by n lambda d by d. Okay, n lambda d by d. What is n? N is 0 plus minus 1 plus minus 2. What is lambda? Lambda is the wavelength of light. What is d? D is the distance between the source plane, source line and the screen. This is capital D. And what is the small d? Small d is the slit distance, distance between the two corresponding slits. So, d is the distance between the slits, and capital D is the distance between the screen and the line of the sources. Okay, generally d is bigger and this small d is in millimeters. Smaller the small d, you will get better resolution. Okay, better resolution of the fringes. Now, intensity in this case is given by I is equal to 4 I naught. So, if the intensity of the first light which is coming from here, okay, say I naught, this is also I naught. If we get a bright spot over here, then the intensity here will be 4 I naught. Okay, so intensity becomes 4 times, not double, it becomes 4 times. Very interesting. Okay. Now, what about the opposite of bright? Opposite of bright is dark, right? Opposite of constructive is destructive. So, let us now discuss about destructive interference. When does it happen? So, if both lights coincide like this, if both lights coincide like this, so you get destructive interference. Okay, suppose this is y1, this is y2, or source 1, source 2. Some points, at some point, if they interfere constructively, then there will be some other points where they will interfere destructively. Okay. So, here the resultant will be like this. The resultant will be very dark, and there will be no light. Generally, if the intensity I1 equals to I2, then dark means completely dark. Okay, there are this is possible that to obtain interference with different intensity, yes, but for your class, your standard, we will assume that lights have same intensity. Okay. Now, path difference, in terms of path difference, what is the condition? Okay. This is also called dark fringes. Okay, dark fringes. Path difference, in terms of path difference, it is slightly difficult. N minus half into lambda. Okay, n minus half into lambda. N is equal to 0 plus minus 1 plus minus 2. Now, you can write this, this sign does not matter, it can be plus also, you will get the same result, okay, because you are starting from n equals to 0. Okay, because you are starting from n equals to 0, let me write it as plus. Okay. So, this is simple. So, n plus half into lambda, where n is 0 plus minus 1 plus minus 2. Again, n has to start from 0, n is integer. Okay. Phase difference, in terms of phase difference, it is 2n plus 1 into pi, same value you have to put it there, okay, 2 pi by lambda into delta x, that is the relationship between the phi and delta x. Okay. Now, position of the dark fringe in this case, position of the dark fringe is n plus half lambda d by d, n plus half lambda d by d, and intensity in this case is 0. Okay. So, it may appear that during interference, intensity of light I naught plus I naught is not always 2 I naught, it is coming out to be 4 I naught. Similarly, I naught minus I naught, it is 0. So, it is appearing that in normal human logic, it might seem that light is getting created at interference maximum, whereas light is getting destroyed at interference minima or destructive interference. Okay. So, for destructive interference light, it appears that because intensity becoming 0, that means light is destroying, whereas because the light is getting 4 times, that means light is getting created, right. But that is not true. Interference is a process where light energy gets redistributed. Energy cannot be created or destroyed. Light is a form of energy, right. So, light cannot be created or destroyed, it can only be redistributed. So, whatever light is getting lost over here, that lost energy is basically getting added to the bright spots. Okay. So, bright spot light gets added, dark spot light gets cancelled. Okay. Now, let us see one question. In Young's double slit experiment, 2 wavelengths lambda 1 is equal to 780 nanometer and lambda 2 is equal to 520 nanometer are used to obtain interference fringes. If the nth bright fringe band due to lambda 1, this is nth, okay, nth means n to the power th, okay, slight mistake over here. So, nth bright band due to lambda 1 coincides with n plus 1th bright band due to lambda 2, then the value of n is. So, basically what they are saying, 2 lights we are using, and at some point the interference maximum are getting coincided, okay, they are falling at the same point. So, what is the value of n? Now, we know that position for nth bright band is given by lambda d by d, and for nth band it is n lambda d by d. Okay. This is the nth bright band for say lambda 1. This is lambda 1, nth bright band. Now, n plus 1 bright band will be n plus 1 lambda 2 d by d. Now, rest of the setup is same. Only the position of these 2 bands are same. So, what is the meaning of that? That means yn must be equals to yn plus 1. Now, put those values, n lambda 1 d by d equals to n plus 1 lambda 2 d by d. So, everything will cancel and you have to just put the values. So, n into lambda 1 was 780. Now, nanometer both sides they will cancel. So, we do not need to worry about nanometer. Another one is 520, right. Nanometer in the left hand side, nanometer on the right hand side, they also will cancel. 0 0 cancels and you can cancel 3 to the 6 and 9 to the 18, 26, 3 13s are 39, 2 13s are 26. So, what we got? We got 3n equals to 2 into n plus 1, right. Just cancel it, or 3n minus 2n equals to 2. So, just break the bracket and bring the 2n on the left hand side. From here we get n equals to 2. So, for the second order of the interference pattern, it will be coinciding, right. So, n value must be equals to 2. Correct answer is option C. Now let us discuss about diffraction. Okay, diffraction is very interesting phenomena. What is the meaning of that? Let us see. Bending of light around a sharp edge is called diffraction. Okay, so normally so far what we have discussed is that light is travelling in a straight line. What does that mean? Suppose we have a sharp edge, light is travelling like this, okay, and at this edge, what is the meaning of that? Light should travel either straight line, okay, it will travel in a straight line path, or if it is slightly below that line, the light will be completely blocked, right. So, this is the basic simple geometric light that we have, geometric optics that we have learned, okay. But light is not so simple. Now we learned about the wave nature of light. So, this point, at this point light will bend at, okay, and you will observe some light over here, not super bright, but you will observe some light over here, okay. So, this is originally in terms of normal ray optics, this should be the complete darkness, this should be the region of complete darkness, but in reality we do not observe that, we do observe some light is actually bending. That means light travels in a straight line, or rectilinear propagation of light may be not 100% true, but actually it is true. What is happening here is that this point is behaving as a secondary source of light, okay. From Huygens principle, this point is behaving as a secondary source of light and it is sending light in all possible direction. Obviously, the intensity will be different, intensity will the maximum intensity will be in this line, 99% will be in this line, 98% will be in this line, and some 1% of light in this, 1% in this direction, right. That is, this is phenomena is called diffraction of light. So, bending of light at sharp edge is called diffraction of light. So, here we have a source of light and a narrow opening. We have a narrow opening, okay, very narrow opening. This opening, not only in this case, also in interference of light or Young's double slit experiment also. So, this slit, this is called slit, this is the opening. The size of the opening should be of the order of the wavelength. Should be of the order of the wavelength. What is the meaning of that? Suppose you are using a say 500 nanometer light, 500 nanometer light, and if you are using a 5 centimeter opening, that means the opening is too large for that light to pass. That means a lot of light will be passing through that opening and you will not observe any interference or even in diffraction, okay. For Young double slit we need 2 openings, in diffraction we just need 1 opening, not 2, only 1 opening is sufficient to observe diffraction, okay. And what happens is that, as you can see, you are supposed to get maximum light in this, which is already happening. The intensity of light is maximum at the center, but some light is bent and it is coming over here, here, but the maximum intensity at the center and the intensity getting slowly decreased as you move up and down. In case of interference, the maximum and minimum intensity are constant throughout the spectrum, throughout the line. If you observe on the screen, you will get equally bright and equally dark patterns, okay. In fact, the central maximum also will be equally bright in case of interference, whereas in case of diffraction, the central maximum or the central position will be the most bright, whereas the brightness will decrease as you are moving away, right. In interference and diffraction, light energy is redistributed. if it reduces in one region, that means destructive interference, okay, producing a dark fringe, it increases in another region producing a bright fringe. There is no gain or loss of energy which is consistent with the principle of conservation of energy. So, interference or diffraction, they do not violate the conservation of energy principle. Energy is conserved in diffraction as well as interference. In future, whenever you will see a question, there will be some options that the energy law, conservation of energy law is not obeyed in interference. That is not true. Energy is obeyed in case of interference as well as diffraction. Okay. Now, fundamentally, even though they are considered to be two different phenomena, the difference between interference and diffraction are not super clear. Okay. Based on the observation how you are observing, okay, interference and diffraction are very close to each other. Also, interference and diffraction is only observable for waves. Okay. It is only observable for waves. Diffraction can be observed for sound waves as well. In fact, interference can also be observed for sound waves as well. So, mechanical waves and light waves, that is EM waves, they both show interference and diffraction. Okay. So, in case of Fraunhofer diffraction, the single slit diffraction that we have studied is called Fraunhofer diffraction, the name after the inventor who discovered it, who created that mechanism and did the experiment. In case of Fraunhofer diffraction, at a single slit, the diffraction pattern on the screen is correct for which of the following statements. So, which of the following statement is true? That is it. Central dark band having uniform brightness on either side. So, is it uniform brightness? So, as we have seen that central maxima is the most bright, 98% bright, other positions are maybe 1% bright. So, most energy is coming towards the central maximum and it is slowly decreasing as you are moving away. In fact, after few fringes you will not observe anything else. Central dark band having alternate dark and bright bands of decreasing intensity on either side. So, as you can see, intensity is decreasing. So, alternate bright, some dark, again another bright, then another bright. That was the pattern, right? So, as you are moving up and down, okay, the intensity of light is decreasing. So, intensity is maximum over here, it is slightly smaller here and it is getting slowly vanished. These are the dark fringes, wherever I have not done anything, that means they are dark. So, these are the brights, okay, this is the bright spot, this is central bright, this is also bright, this is also bright, these are the dark positions. And intensity decreases as you move up and down. So, this is the correct statement. Central bright band having dark bands on either side, okay. Central bright band having dark bands on either side, dark bands we do not say dark bands. Central bright band having alternate dark and bright band on the decreasing intensity on either side. This is also correct. Okay, both are same statements. It should be one of them should be increasing, one of them should be decreasing, but both statements are same. Alternate dark and bright, alternate dark and bright, not only dark. So, this is not correct because central bright fringe with, if everything was dark, then C would have been correct. But what we get, alternate dark bright, dark bright, dark bright, like that. Okay, so alternate dark and bright on either side and intensity decreases. This is also correct, but it should be increasing, not decreasing, so that we do not have any confusion. Okay, increasing intensity on either side, this is not correct. Now, this is a completely new phenomena. Okay. So, previous two phenomena, that is interference and diffraction, can be observed for sound waves as well. This is a particular phenomena, polarization, which can only be seen for electromagnetic waves, sound waves or any other mechanical wave, spring wave or any other wave do not show polarization other than any electromagnetic wave. Light showing polarization is the greatest proof that light is a electromagnetic wave. Only electromagnetic wave shows polarization. Only electromagnetic wave shows polarization, and this is a proof that light is a electromagnetic wave. Okay. We will see in detail, little bit in more detail when we discuss the chapter electromagnetism. Okay. Or electromagnetic waves, sorry, not electromagnetism, electromagnetic waves chapter, where how the electromagnetic wave is being produced, that will help us to understand this phenomena polarization. But for now we just understand that when light propagates, suppose this is the direction of propagation generally represented by z axis. Okay. There will be one associated electric field and one associated magnetic field. Okay. When light is propagating in one direction, there will be an associative electric field and magnetic field, and both of them will change like oscillation. Okay. So, oscillating electric field and oscillating magnetic field, or time varying electric field, time varying magnetic field. Some difficult terms I know, okay, but you have to be familiar with these terms. Slowly we are moving up in the second PU, right. So, you have to learn these terms. So, when electric field varies with time, we say time varying electric field, nothing rocket science, right. So, if electric field is varying with time, we say this is time varying electric field. If magnetic field is varying with time, we say time varying magnetic field. Okay. So, electric field and magnetic field both are varying with time, and that actually produces electromagnetic wave. Similarly, light also do have this property, and they also produced by varying electric and magnetic field. Light waves are transverse in nature, that is, the electric field associated with propagation of light wave is always at right angles to the direction of the propagation of the wave. Light waves having electric field in all possible direction is called unpolarized light. Now, let us understand this. So, from now on we do not consider the magnetic field. Magnetic field is there, magnetic field is required. In fact, electric field, magnetic field and light propagation, they are mutually perpendicular. Okay, like this left hand rule. So, this is the propagation, one of them is electric field, one of them is magnetic field, this is the propagation of light. Okay, just take your left hand, this is the propagation of light, this thumb, suppose this is the electric field, then the other finger will point towards the magnetic field, right, like this, right, clear. So, this is how it is there, but magnetic field, the magnitude of magnetic field is very small. Okay, so, we do not consider magnetic field, only electric field is sufficient to describe any light. So, suppose this is the electric field. Electric field, what it says, that what is the direction of electric field with respect to the direction of propagation? It is always perpendicular, right. Now, how many ways you can draw perpendicular to a straight line? How many ways you can draw a perpendicular to a straight line? You can draw like this. Look at me carefully. It is very, very important. So, this is a perpendicular line, right. This is a straight line propagation. Suppose this is the direction of propagation of light, okay, and this is the perpendicular. This is the electric field. Okay. Now, you can draw it like this, and then you can, this is also an electric field, this will also be an electric field. Every point it is a 90-degree angle only, right. All such points are 90-degree angles only. So, you can draw a electric field like this, you can draw an electric field like this, 3-dimensional. Okay. So, it is a perspective view. Okay. I cannot draw it 100% on the board. Okay. There will be an electric field like this, electric field like slightly at some other angle as well, but okay, but this angle is always 90-degree. Okay. Even if the perspective changes, even if you rotate it in this any point along this circle, okay, electric field will always be perpendicular to the direction of propagation. right? Clear? You can try it using two pens, okay, make them perpendicular to each other and say that, okay, even if I rotate it, the electric field will always be perpendicular to the direction of propagation, right? So, light, normal light that we observe coming from sun, coming from sources, okay, here all possible electric fields are present. All possible electric fields are present. It is called unpolarized light. It is called unpolarized light. Okay. If an unpolarized light wave is incident on a special crystal, if unpolarized light is allowed to pass through certain special crystal called tourmaline, okay, quartz, okay, if they are allowed to pass through them, then the light wave will get linearly polarized with the electric vectors oscillating along the path axis of the Polaroid. It is called polarization. So, when you allow this light to pass through certain crystals, what is the crystal? They are called quartz, tourmaline, very special crystal obviously, and generally we draw them like this, okay, octahedral structure, and this is the path axis. This axis is called path axis. So, once the lights are allowed to pass through this, okay, only one of the electric field remains, remaining all electric fields are gone. Let me redraw it little bit clearly, so that you do not have any doubt. Suppose this is the original light and it is allowed to pass through a tourmaline crystal. This is the path axis. So, once the light pass through it, after it coming out of the crystal, only electric field which is parallel to this axis, only they will remain, okay, remaining all other electric fields will vanish. Remaining all other electric field will vanish. This phenomena is called polarization. This phenomena is called polarization. The intensity of the polarized light is half of unpolarized light. Very, very, very important line. So, if the intensity of the light which is entering the Polaroid is I naught, if the intensity of the light which is entering the Polaroid, this is called polarizer or Polaroid. Polaroid is general term, okay, polarizer is the first Polaroid which facing the light, it is called polarizer, okay. So, the intensity which is coming out of the polarizer is I naught by 2, it is I naught by 2, this becomes exactly half of the intensity of light. Okay, now, this phenomena has a lot of applications. Okay, the primary application is that when you wear a sunglass, if you wear sunglasses during the sun, okay, when you are going out in the sun during the day, okay, your eyes feel relaxed. Why? Because there is a Polaroid coating is given on top of the sunglasses. Now, there are two types of sunglasses, one is cheaper one, okay, 100 rupees sunglass. What they apply? They apply simple reflective layer, light comes falling on the eyes and they get reflected, only part light comes in, okay. But what happens in that case, you may miss some of the objects in front of you, your visibility may not be good, okay. But if you are using polarizer, sunglasses, then what happens? For costly sunglasses generally use polarizers, okay, that is why the price of sunglasses vary from 100 to 20,000, right. The sunglasses that been worn by the cricket players or football players or some other sports players, okay. So, they are very, very costly because they use polarizers, and all the lights do reach in your eye, but the intensity of the light just becomes half. That is the beauty, okay. All lights do reach in your eye, but because of the polarizer, the intensity of light becomes half, okay. And That is how polarizer work. And one more another thing, if you next time, last thing I remember was Jurassic World movie that came last month, and if you have watched that in 3D, then that is basically thanks to this technology. Okay, the 3D movies generally uses Polaroids to record and Polaroids to show it to you. So the glasses that you wear while watching the movie is basically pair of Polaroids. There are two Polaroids in your eyes, and it helps you to see things in 3D. Okay. If you are interested in how do we watch 3D movies, you can mention in the comment below. I will make a separate video on that. Also, if you remove in the theater, if you are watching a 3D movie next time, try to remove your Polaroid sunglasses, and you can see how the screen looks like. Okay. Now, next that we are going to discuss is Malus law. It is the most important formula for all KCET students. Very simple, but almost each and every year. Last year it did not came, but before that, each and every year there was at least one question based on Malus law. There is only one exception in 2025. There was no question on Malus law, but other than that, from 2015 till 2024, every year I have seen questions from Malus law, directly or indirectly. So what is Malus law? Let us understand first. We have two Polaroids. Okay, this is called, first one is called polarizer, second one is called analyzer. Both are Polaroids. This one is called polarizer, and this one is called analyzer. Okay, analyzer and polarizer. Now, what does it do? Polarizer polarizes the light, incoming light. Analyzer analyzes whether the light which is passing through it is polarized or not. Okay. Now, if both of them have the same parallel configuration, both of them have same parallel configuration. So, light which is entering here is I naught. So, here it will be I naught by 2, and in this case also it will be I naught by 2, because they are parallel. Now, if you keep them at certain angle, if they are not parallel, now if you cross them and if you will find some angle between them. Okay, so this is the original, this is the cross Polaroid. Okay, if the angle between them is theta, if two Polaroids are not at parallel or not at 90 degrees, 90 degrees it will be 0 anyway. If Polaroids are kept at certain angle, okay, polarizer and analyzer, they are kept at certain angle, then what will be the intensity of the light coming over here? So, this is the intensity I, this is I naught by 2, what will be this intensity? Okay. Generally for Malus law, we do not consider this intensity, we only consider this intensity. Okay. But when solving questions, it is very important to take care of this intensity as well. Okay. We have to consider this intensity as well when solving questions from Malus law. We will solve one question, do not worry. So, Malus law states that the intensity of the final light which is coming out of the analyzer is given by I naught cos square theta, where theta is the angle between polarizer and the analyzer, where theta is the angle between polarizer and analyzer. Clear? If you have any doubt, do not forget to mention that in the comment of this video. Now, let us see a question. 3 Polaroid sheets are coaxially placed at indicated in the diagram. Pass axis of the Polaroids 2 and 3 makes 30 degree and 90 degree with the pass axis of the Polaroid sheet 1. If I naught is the intensity of the incident unpolarized light entering the sheet 1, the intensity of the emergent light through sheet 3 is. Okay. So, let us see. So, here we have a first Polaroid sheet, and according to our definition, this is the polarizer. The intensity of light which is coming unpolarized, its intensity was I naught. So, once it is passed through the first Polaroid, what will be the intensity? Intensity will be I naught by 2. Simple. Now, if you see that the second Polaroid has an angle of 30 degree. Second Polaroid has an angle of 30 degree with respect to the first one. So, what will be the intensity over here? So, intensity over here, say I1, I1 will be I naught by 2 cos square 30 degrees. Okay, cos square 30 degrees. Now, what is cos 30? Cos 30 is root 3 by 2. So, cos square root 3 by cos square 30 means 3 by 4. So, it will be 3 I naught by 8. 3 I naught by 8. Now, this is 3 I naught by 8 we have calculated. Now, if the light passes through this again, now we will not consider the angle between first one and last one. That is not Malus law. Malus law is the angle between this one and this one. So, the angle with the first one is given 90 degree. Here the angle with first one is given 30 degree. So, what is the angle between these two? So, angle between these two will be 90 minus 30, that is 60 degrees. Okay. So, in this case theta will be 60 degrees, right. Now, we will use again another Malus law. So, I2 will be this intensity 3 I naught by 8 cos square 60 degrees, that is 3 I naught by 8 into 4, 1 by 4. Cos 60 is half. So, half square is 1 by 4. So, from here we get 3 I naught by 32. Okay. So, correct answer is this one, right. Now, it is time for us me to give you some homework. So, homeworks are given here. You can pause the video, read the question, answer it immediately and mention the answer in the comment below. Also, if you want to download the PDF of this lecture, then definitely you have to join our WhatsApp channel. We will share the link there. From there you can download all the lecture PDFs including the past ones, and whenever we are going to publish a video, all the future videos, we will share the PDF links from our WhatsApp channel. So, do not forget to join the WhatsApp channel as well, right. First question, this is the second question. Again pause the video, try to answer it and mention the answer in the comment below. I will check it and I will reply it back to you if they are correct or incorrect, right. Pause the video, answer it and immediately reply back in the comment section. Okay. And here is the toppers who came to our office and meet with us. So, if you want to feature over here, then definitely have to study hard and score well in upcoming KCET 2026 exam. Then you can meet us in our office together and we can have a lunch together, right. With this I can say goodbye. I will be back with the PYQs of KCET from this chapter.